So I'm putting the Gretl download file in WhatsApp group, which I already have. So those who are not able to download it right now can go to the WhatsApp group. In 5 minutes, 2 minutes, you will get it. Download it, install it, go step by step, and it will be done. So fine, I'll do that. Dr. Malik, we can now start the session formally. I'm sharing the file with participants in the WhatsApp. They can do that.
Yes. So I request all those who have raised their hand, they can down it quickly. Thank you very much. Dear participants, good evening, everybody. As we are on our journey, today is our third day. And today we are going to learn our session 2, where from Econometrics, is going to start. We are going to learn econometric modeling from scratch. And our session is namely Foundations of Econometric Modeling with hands-on session on Gretl. So I welcome our resource person, Dr. Bhagirath, and our moderator for today's session, Ms. Deepti. So I welcome you on behalf of Jammu and Kashmir Economic Association and General Center for Global South. So over to you, Ms. Deepti. Please go ahead.
Yeah, thank you so much, sir. Very good evening to all of you. I am Deepti Bapna, working in the loans department of Saraswat Bank, handling the retail and commercial loans mainly for the branches. I handle the Ahmedabad branch for the loans, and it is a great opportunity for me to moderate the session for our esteemed professor, Dr. Bhagirath Baria. Dr. Bhagirath Baria is serving as an assistant professor at our department, Banking and Insurance, Faculty of Commerce, the Maharaja Sayajirao University, Baroda, India. He teaches the quantitative techniques, risk management and related subject at the postgraduate level. His area of research includes the applied macroeconomics, including the microeconomics of banking, international finance, agricultural economics, with strong focus on applied econometric analysis. He has also published in leading and reputed journals, has trained students, professionals on applied econometrics in India and abroad as well. He has authored full-scale book in economics published with Routledge and continues to pursue high-quality research with both national and international collaborations, especially in the domain of economic, banking, and international finance. He is deeply passionate about improving the empirical skills of researchers, teachers, and emerging scholars. So very welcome you, sir, and I hand over the session to Professor Dr. Bhagirath Baria for an insightful and thoughtful process. Please, sir.
Thank you, Deepti. Very nice to have you on board. All of you can mute yourself now, and we will start with the session. And I don't need to go for much of formality. I and Dr. Malik, Team Jammu and Kashmir Economic Association, we are working hard to bring a wonderful workshop for all of you. As you know, yesterday there was a discussion by Dr. Parmit, a very good friend of mine, and he laid the foundations of fundamental statistics. If you understood what he has discussed, and if you study what we will be sharing with you, I am preparing a session-wise folder in Google Drive link where you will have, for each session you will have content, and it will keep on getting updated. But I need a little time. Myself, Dr. Malik, we all are already full-time employees. We are working full-time, and then we are managing this thing also. So just bear with us for a day or two more, and you will definitely get it. So let me share a screen with regards to my session. And those who are facing problem in downloading or installing Gretl, don't worry about it. We will take it up later. All right, let's not worry about software. Software is not our priority. So let me share a screen with you. Just a minute. Now I have shared a screen with all of you, which is my presentation for today. And I hope the screen is now visible. I'm sure it is visible to all of you. And the title is Foundations of Econometric Modeling using Gretl. The idea behind this session is to bring something on table which is not generally touched upon in traditional workshops. I see large number of workshops going on across the country. Many of them are wonderful. Many of them are all right. Many of them are fine. They don't really touch the issue in depth. One thing I have seen missing across all levels of quantitative or empirical or even qualitative modeling related workshops is the philosophy of empirical analysis is not touched upon. Now, one of the reasons for having the keynote session from Professor Shanmugan was to uh, bring this philosophy of empirical analysis to you. And this session is, you can consider a more relatively easier version of what Dr. Shanmugan had touched upon, but in a different flavor. The way I would like to see it, him being my mentor, I definitely would have a thought process which is like his. So I'd like to share that with you. And laying the foundations are very important, because whatever comes further will depend on how well you grasp the philosophy of what you are doing. You know, this philosophy is something very interesting. You need to understand that and realize that before you engage in it. All right. Before I continue, Dr. Malik and others, my audio is fine. All right. There is no issue with my audio.
Yes, sir. Yes, sir.
All right. All right. Thank you so much. So I'll just shift a little bit up. Okay. So I am hopeful that I'm clearly audible, and now I'll start the discussion. All right. Many people could install with the file that I've shared in the WhatsApp group. Great. All right. Now keep the software aside. Okay. Forget about software. Forget about econometric technologies. Let's get into econometrics now. And the session that I'm taking, this is the broad overview of what I'm going to talk. Some of you might have attended my previous session also in another workshop, but there are lots, considerable differences than what I discussed there and what I'm discussing here. Of course, there are some common issues also, but there are considerable differences also. So these are the 7 things that we are going to look at. We will look at what does it mean to think using models, and then we will look at what does it mean when we use the term equations. All right, that's very important, knowing what the term equation means, because in econometrics, whether you are in management, whether you are in HR, whether you are in accounts, whether you are in banking, whether you are in insurance, if you're dealing at a mid-scale or above mid-scale position, you will be dealing with a lot of data. And when you will be dealing with a lot of data, you can't analyze each variable as something new. You need to bring them together into a systematic framework, in a systematic framework, which will include many variables together. That's an equation. And then we will look at various models that are popularly used in empirical analysis. Let me mind you well, when we use the word empirical, all kinds of data are included, whether the data is numerical, qualitative data. For example, if you have preference data, ranking data on a Likert scale, which is very popular in management studies, consumer satisfaction surveys, that also is to be termed as empirical data. Okay, when we use the word empirical, it means you have collected it from the real world, or you are using a data that was collected from the real world. Then we will look at what are the main elements of an econometric model. What does it mean to use the term econometric model? How does it look? What is its main structure? And we'll look at some very nice, interesting, very latest relevant questions, practical questions that we can answer using econometric models in 7 to 8 different subjects, including military science. So if there is a military assessment going on, for example, a planning of a war going on, how would you use econometrics? And mind you well, the most popular econometrician on planet today is Damodar Gujarati. I'm sure many of you must have heard about his name. His book is like the Bible of econometrics. Uh, Damodar Gujarati, he himself has been teaching at the US military academy. For military also, they have an academy. So he has been teaching there since last many years. So you can understand how vast the application of econometrics is. So it doesn't matter if you are from management or any of its branches, from economics, from finance, from sociology, from political science, from public administration. Econometrics is not about economics. It's about dealing with data and trying to make sense of how the world is working. Finally, we'll go for hands-on session with Gretl using the data set that I have already shared with you yesterday, student performance data set, all right, which I have already shared in the WhatsApp group. And those who are not in WhatsApp group of something else, I'll share in the chat box also later on before starting that hands-on session. So don't worry. Finally, we will look at modeler's toolkit. What are the essential 3 skills that I feel a smart modeler in today's world should know? So we'll start with first topic, model-based thinking. When we say model-based thinking, theory is the foundation. Dr. Shanmugan was talking about it. Keep looking at theory. What is this theory about? It is how the things work. You know, how the things work. For example, if you are an HR professional, how do employees decide which firm to stay, which firm to leave, or what determines the number of years an employee will spend time in your company? What determines attrition? Very important. Let's say you are a mutual fund manager. You are handling thousands and crores of dollars worth or rupees worth of mutual funds of a firm. Now, a question comes: how frequently should you buy and sell uh, mutual funds? Okay, I request you all to stop writing about WhatsApp group in the chat box. It is disturbing me and others also. So we'll take up later. Now focus on the session. Try to gain knowledge. Okay. So suppose you are a mutual fund manager and you are getting, you are looking at the markets and markets are moving up and down, and you need to decide, should you start churning? You know, they in accounts and finance they call it churning. How frequently you rotate your mutual fund portfolio, and applies to you also. If you have a stock portfolio, how frequently you rebalance it? That's churning. So how much to churn? So that also depends on the theory of financial economics. You know, investment theory, financial economics theory, finance theory, accounting theory, they have answers to such questions, or rather I would say indications for such questions. So theory is the heart of everything. You should have a framework in your mind how things work, and then you go on the ground and you know, start collecting primary or secondary data and start creating variables and do all the modeling and quantitative stuff later on. So how does theory come? Theory comes from literature. If you extensively study literature, spend time on literature, you will get theory. You will know what is going on, because in articles, in good quality articles, there is always a section on theoretical background or theoretical underpinnings. If you see good quality articles published with good publishers having good indexing and ranking, you will always find a section on literature review, within which they will talk about the conceptual framework or the theory that they are using. You can also get theory from your experience. You know, if you're a professional, let's say you are a mutual fund manager working for last 20 years in the mutual fund industry, you know very well how things work. I mean, you don't need to study any literature for that matter. You know how things work. If you're working in a corporate company for last 10 years, like you will be meeting Mr. Dwarkesh Panchal on the last day on machine learning. Okay, he's working since last 10 years in corporate industry. He knows how data science departments work, how data analytics works. So he knows the theory of how to work with data. So that experience also guides you along with literature. Then there are rules of thumbs, you know, well-established protocols, well-established rules. Uh, those who are in marketing, for example, they must be, or management sciences, those who are in any of the management sciences, they must be conducting systematic reviews of literature. Economics, I don't see much popularity of that. We should be doing that. But in management, there is a lot of importance to systematic reviews. So they have protocols like Prisma, then SPAR for SLR. You know, there are a lot of such protocols there, rules of thumbs, how you should go about collecting literature and how do you organize it. And then there are other ways. If you don't have any theory, you are doing something which has no theory in it, background, it's something brand new, then go for data mining or go for experiments like randomized control trials. But work on theory. Get some idea about theory. That is how things should be working in the real world. So that when you start dealing with data and start estimating things, there should be a logical structure and coherence to what you have done. All right. Very important to understand, the theory is the guiding force for econometric work. Which theory? Your subject theory. If you are in HR theory. If you are in marketing theory. If you are economics, say financial economics theory. If you are a macroeconomist, macroeconomic theory. Theory is what guides you before starting anything. Fine. So a very common debate in econometrics is whether you should start your work before knowing the theory, or you should learn theory on the way. It's like on the job training versus doing an MBA before the job. So there are two candidates in front of you. One who has done MBA from a very good institute, has performed well, has done a lot of projects, has done internship. Another is not an MBA, a BBA, but has worked for last 10 years in a very big sophisticated company. Both have learned how things work. One has learned through a theory framework. They have developed understanding of different theories, the MBA person. Another has learned through data mining. They have gone on the ground, worked, faced the issues, taken a call, understood, okay, this is how things work. So in econometrics also, we have this very strong debate whether you should work on structural modeling. By structural, we mean having a structure in advance. What is a structure? Your theory, your X variables and Y variables. We will look at them. Okay, we will start from scratch. Those X and Y variables, like for example, in HR, companies' wages, salaries, and attrition, that is how frequently employees are leaving and rejoining, new employees are joining, that's attrition rate. How are they related? Salary and attrition, or salary and job satisfaction. So these are the variables you want to know. Now structural modeling says you should have some idea in advance. You should know the structure of how these are related, what should happen between them, which should come first, which will come second. But data mining says don't do that. You test them. There are some econometric tests, perform them, and then decide which one should come first, which one should come second, which one should affect the other, how it should affect. So this is one very important debate. Two kinds of theory are there. Actually, I've written economic theory. It should be subject theory. See, I've written the word subject theory here. You can see that. Whatever subject you are in, sociology, management, that subject theory, and then you have to combine it with econometric theory. So the workshop that we are focusing on is on econometric theory. Your subject theory comes from you. How good are you in your subject? If you're an accounts person, finance person, HR profession, marketing person, economist, macro or microeconomist, how good you are in your subject is up to you. This workshop will help you build the skills necessary to become good in econometric theory. All right. So one of the best ways to improve econometric theory is to engage with people, attend workshops, meet good workshops, quality workshops, interact with good quality people who are working, doing serious work, engage with them, contact, make network. You will learn a lot, not only by reading, but even by interacting with people. A fundamental question in econometric modeling is about causality, cause and effect relationships. What causes what? This is the fundamental aim of doing any empirical research, including econometrics. Any empirical research has to deal with the problem of causality. By causality, we mean cause and effect relationship. Now, I am a strong believer that cause and effect should be known in advance before even you start collecting data. This is very important. Before even you start collecting data, whether it's primary or secondary data or both mixed, whatever it is, you should know what are the variables of your study and how variables affect each other, or how they should affect each other. You don't know how they will affect each other. That you can only know after doing your estimation in econometrics. But how should they affect each other? You should have that idea in advance. So again, how will you come to know about it? You will come to know about it from here. do a literature review, use your own experience, look at some rules of thumbs in the subject, interact with experts, talk to them, spend time like that. You will come out with a very good model if you do all that. So causality is something you should know in advance. Correlation is something that you can discover with data. Something is correlated, that you can discover when you are dealing with data. But causality is something you should know in advance. And a very, very common question that comes is, many people face this, that sir, if suppose we have two variables or five variables, okay, and you estimate a correlation matrix, that is, say, variable 1, its correlation with all four variables, variable 2, correlation with all four variables, variable 3, correlation with all four variables. So you see their correlation amongst themselves, and if all the correlations are very small, does this mean that there is no causality? I mean, they are not correlated at all. There is no common movement between them. As a matter of fact, I would say that's a very good uh, platform or a very good development or a thriving environment for causality to emerge. Right? If there is too much of correlation amongst your variables, there is not enough information, unique new information in your data set. Your data is repeating the same thing again and again. Those who are professors here at any level, who are working as teachers, professors in college, in school or universities, there are some students who, when they write answers, you can see they are repeating themselves. They are not having that clarity. But there are some who will write very well. They will write short, but they will write very well. They won't repeat. So when there is a lot of correlation in your data set, that's too much of repetition of the same information. So perhaps you should look at removing some of the variables and bring some new dimension in the study. So don't ever confuse correlation with causality. Even if correlations are low, no problem. That's actually a good thing. You are having different kinds of information. So your hypothesis testing, your overall model will have a lot of unique information coming together. So in social sciences, it's very difficult to establish causality. In pure sciences, also it is difficult, but they do have one tool known as randomized control trials, like medical science. All right, they have RCTs, and where in economics also they are using nowadays. But randomized control trials, what they do is they create a situation, create two groups, treatment and control, create a placebo effect, give treatment to one group. They don't let any of the group know who is the treatment, who is the control group. Both feel that they are the treatment group. And then they put a stimuli or put a change, see how it works. You see scientists doing that in laboratories, and economists also do that in the study of poverty. We have two big economists, Abhijit Banerjee and Esther Duflo, Nobel laureates, who are well known in using RCTs, randomized controlled trials in economics. So they have that tool where they can control things, create a pure situation, and then see how something affects one change from outside the system, something that changes from outside the system, how it affects the treatment and control group, which group is affected and how it is affected. But in social sciences, we don't have that. For example, if the government wants to know that if we increase the tax rate by 5% on certain goods or services, how will it affect people? You can't experiment that for a short time and see how it affects some of the people. You don't have that luxury. For example, if you are having a set of students and you want to know what will happen if I ask my students to go to library 2 hours every day. You can't change the rule one fine day in morning in the university and announce that now every student will go to library 2 hours every day. Well, so in social sciences, we have a lot of constraints. There are ethical issues also. Can you do such large scale experiments? Okay, RCTs are being used in economics, but they are at very small scale. They can't do it at national scale, regional scale, international scale, global scale. There are questions in management theory, like international business theory. There are questions in international finance, which connect countries. How would you do an experiment there? I mean, there is no way out. All you can do is you can capture the past. You can take the past data, and then from that past data, you can use econometrics and try to capture causality. Okay, so you try to capture causality by Just a moment. Yeah, you try to capture causality by looking at how X and Y are related. Okay, so that's correlation. You also, using econometrics, let me move this. Yeah. You also capture how X causes Y. So if X is related with Y, that's quite fine. I mean, X is related with Y, you know that. But if X is causing Y, how do you know that? Correlation is something you can find out with data set. But how do you know whether X is causing Y? Because you can't experiment in the real world. So you can use econometric models to answer this question. How X affects Y, or X1, X2, X3, X4, X5, however many X's you have, how they affect your Y variable. So econometrics gives you that ability. What ability? It allows you to overcome the limitations of social sciences. That is, we can't conduct randomized controlled trials or experiments at a large scale. So if you want to ask big questions like how to reduce inequality, what if we increase tax rate, how will income inequality be affected? Or in your company itself, in your firm itself, if you increase the wage or salary, how will it affect productivity of employees? You can't go around experimenting it. These are not decisions that you can experiment, introduce for some time, then reduce the salary. See, those who are in HR and economics, they know there is downward price rigidity. You can increase the wages, but if you try to move it down, it will be a problem. There will be resistance. So you can't experiment these things. That limitation of not being able to experiment is fulfilled by econometrics. Okay, it allows you to do experiments. Okay, it allows you to do experiments. I would say not pure experiments, quasi experiments, QUASI, quasi experiments with data. Fine. The second important thing is, what are equations and why are they important? Because we are going to study a lot of kinds of equations in this workshop. So this is the fair idea I would like to give you. Equations are functional relationships between at least two variables. When we say functional, that is, one variable is a function of another variable. What I mean function, Bhagirath's, Dr. Bhagirath's expenses every month, the food he eats, the places he goes to travel, the money he spends, is a function of his monthly income. Fair enough. Easy to understand. So there are so many variables which are functions of so many other variables. But when you take that and put it in a formal mathematical form, we say it's an equation. Now, why is it important? It is written here in the third point. They provide a structure to what you wish to analyze. Equations provide you a structure to what you wish to analyze, and it makes your assumptions and beliefs very transparent. So you are very clear, what is my Y, what are my X, how they should be related, what are my assumptions. You are very transparent and clear, and that is how scientific knowledge can be generated. If you have an equation and you are using it, but you are not revealing it, then others won't be able to test it, check it, or confront it, or criticize it. For example, in India, those who are not from India might not be able to get it, but in India, there are a lot of mutual funds. I'm sure most of you know what are mutual funds. There are a lot of mutual funds in India. There are some mutual funds in India which are known as quantitative mutual funds. They work on quantitative algorithms. So there is a group called Quant, QUANT, Quant Group, whose mutual funds are giving phenomenal returns. 38%, 40%, 42% per year compounded. Can you imagine 40% per year returns compounded for last 5 years? Phenomenal growth. Your money must have tripled or quadrupled in 5 years. You put, say, $1,000, it would have become $5,000 in 5 years, just by keeping it in those mutual funds. So this quant group is using quantitative algorithms, and there are a lot of equations they are using, but they are not revealing it. Okay, naturally, it's their business, it's their trade secret. They are not revealing. But they have an equation. There are multiple equations. RBI, Reserve Bank of India, or whichever country you belong to, your country must be having a central bank. The central bank has a very large scale equation which it uses to understand what is going on in the economy, and then decides what is to be done. Increase the interest rates, keep the interest rate constant, reduce the interest rate. Okay, so there are a lot of there are a lot of things going on in the real world which are explained by equations. But just because we don't know the equation does not mean that it is not there. It is there. We don't know. I am sitting online using internet, interacting with people from all over India and all over the world. We have so many international participants. How was this possible? Through technologies, internet, data sharing. All of these are based on mathematical principles, which are equations. But we did not know about these 100 years ago. We know about it now. Does it mean that those equations were not there 100 years ago? No, they were there. We could not know, or we were not in a position to know. Today we know it. So the simplest way to talk about equation is y, which is your variable of interest. We call it the dependent variable. It is dependent because it has no existence independently. It needs some other variables to give value to it. It needs other variables to change so that it can also change. So we have dependent variable y. This is the problem you are interested in. If you're working in a company, if you see that your profits are not increasing, then your profitability becomes the dependent variable, y variable. If you're an academician and you are observing that your students are not performing well in the exams, despite having taught very well, their performance becomes the y variable. And that's our case study also as for today, student performance. But y variable is dependent on something. So what are those variables on which y is dependent? The independent variables. That y variable, dependent variable, comes from the problem you are facing or the issue you are trying to analyze. It's possible you can have multiple y variables. You may have y1, you may have y2, you may have y3. Getting it? For the same problem, same issue, you may have multiple y variables. So you can use each of them one by one and then see how your results behave. That's one strategy, and that's actually a good strategy. We'll discuss about it later. So what explains the y variable? The independent variables, the variables which are determined by something not related to y. They are determined by something which is not related to y. So y has no influence on them. So how do you write it? In the simplest form, we say y is a small f function of x, single equation model. Y is a function of x1, x2, x3 up to xn. It's an n variable regression model. It can be 3 variable, 5 variable, 15 variable, 200 variables, whatever damn you want. It's up to you. In econometrics, we have a specific way of looking at these equations. We use the expectations operator, the E operator. We say that expected value of y is a function of x1, x2, x3, etc. Now, many of you might think, what is this E doing here? Why have we introduced it? Tomorrow, we will get deeper into that E, why it is so important in econometrics. Irrespective of the subject you are working on, you need to understand this expected value of y equation very well, okay, which is what a regression does. Fine. So equations capture motion. I'm really fascinated by the laws of motion. Those who are from science background must be knowing them. Equations, societies also go through motion, companies go through motion, your body goes through motion throughout the day, your temperature changes, increases and decreases, you know, the air quality around you changes. At molecular level, your cells and atoms and molecules are also moving. There is motion constantly. Countries are moving, GDP is moving, sectors are moving, industries are moving, whether up or down doesn't matter, they are moving somewhere. Motion is everywhere. And to capture that motion, you need equations. Because motions complicate the matter. If things are moving, it's very difficult to keep your x's and y's together. If things are moving, x1 is moving here, x2 is going there, x3 is going there. So y will also move here and there, and there is a lot of complex activity going on. So equations compress everything and put them in very clear, cut, easy to understand manner. That's what equations do. They capture motion. Very important to appreciate that. The fundamental role of any research in any subject is to study the dependent variable, not the independent variables. I see researchers who first locate the independent variables, X variables, then find out through trial and errors called iterations in software which dependent variable are these independent variables suiting well. No, that's wrong. It always starts from the dependent variable, the Y variable. This is the foci of our thinking. This is the focus of the scientist, the social scientist, whether you are a sociologist, public administrator, HR professional, marketing professional. The dependent variable is what you should be looking at. That is from where your research and all your study should start. All right, you should not start from independent variables. What are the dependent variables we can think of practically, very concretely? For individuals, they can be their salary. For businesses, they can be their profit. For a community like your society where you are living or housing community, water supply can be a dependent variable because you want to study or know what is affecting your water supply, how to maintain smooth water supply in your society, in your community where you are living. For the overall society, national level society, income inequality can be a variable. Society is concerned, people are concerned, why is there such large gaps in income of people? For global economy, the geopolitical stability can be the dependent variable, Y variable, the issue you want to study. For example, there are a lot of wars going on right now, Israel, Iran, and Hamas war. We have Ukraine, Russia war. So there are fears that more escalations may occur. So international political economist or a geopolitical expert would like to study international geopolitical stability, how to maintain it. It will become their Y variable. Now they will start finding the X variables. That's the correct way of doing research. Never start with your X variables and then find out which is the most suitable Y variable. You might ask, what is the problem in that? Come on, it's one and the same thing. No, the statistical properties of your estimates of the econometric methods you use will go haywire if you do that. All right. So that's all I can tell you. What exactly happens? What's the issue? A lot of dense maths is involved and a lot of theoretical arguments are there. Let's not get into that, but try to understand. You should always move from the Y variable to the X variables. You should locate the Y variable. What is it you want to study? How to measure it? Now you start looking at X variables. How would you do that? Again, that first slide that we went to, this one. How do you find those X variables? That is a theory. What explains Y? That is the theory. X variables explain Y. So the theory will help you to find out the X variables. Okay. How? Literature review, use your experience, rules of thumbs, etc. Whatever we discussed. Let's look at types of models that are very popularly used in econometrics. Thinking like an econometrician or a modeler means you look for relationships. Many times you don't know what are the cause and effect relationships. So what you do is, let me have water, just to. So what you do is you look at correlations, and from correlations you try to get some feel that there might be some causality or cause and effect relationship. You know, even if correlation is not there, cause and effect can be there. But if correlation is there, it's not very high, but it's there. There can be a first indication that there might be some cause and effect relationship. There might be some equation lurking behind this. Some hidden equation which you need to find out. Now, which is that equation? What exactly do we mean by this equation? Tomorrow's session, I will explain you very concretely. Okay. So once you have found out the variable Y, which you are interested in, undertaken the research, understood the theory, found out the X variables. So now your Y is clear. Okay. And then your X1, X2, X3, X4 are clear. Great. It's now time to get into modeling work. Okay. You have collected the data on X and Y. Now you can get into modeling work. You can do quantitative as well as qualitative modeling. In both the cases, econometrics is absolutely wonderful to use. Doesn't matter if your data is a Likert scale data of ranking. For example, if your data is on gender, or if your data is on questions which have 3 answers, yes, no, can't say, absolutely fine. Econometrics has all kind of tools to handle them. Okay, it doesn't matter. There's a very good question I have raised. How will artificial intelligence impact your career in the next decade? All right, just a moment. How will AI affect your career in the next 10 years? Now, this is a very important question which can be answered through a model. So in this model, we will have to have a y variable and x variables. Now, by now, who have understood my session, by now till now, will understand the y variable will be career. Okay, careers here. The career word is your y variable. And what will be the x variable? Of course, AI. So your y is clear. You are not interested in AI. You are interested in careers of people. But you want to understand careers through AI. So career is what is you are interested in. So you start collecting literature on what determines career of people. What determines their job security. What are the different factors? One of them will be AI. You are interested only in how AI affects it. But you need knowledge of other variables also. All right, fine. So these are the major models. There are visual models. There are mathematical models. We will look at maths and mathematical and statistical models tomorrow. What do they mean? And then there are econometric models. Econometric models take up both mathematical and statistical models, combine them with your theory, HR, marketing, economics, whatever it is, and then they create equations for you. It's all about equations. In the end, you are dealing with equations. But like a mathematician, you don't need to create equations. That's the beauty of econometrics. It has well-defined equations for you. You need to know which equation to use when. You don't need to create equations. We are applied econometricians. We are going to apply econometrics in our area of study, in our business, in our company, in our personal life, in our professional life, whatever it is. You don't need to create equations. All kinds of equations are there in econometrics. You need to understand for your specific problem, which is the best equation. All right. So this is the broad framework of econometrics. What I hope I am audible. Just check. Somebody had written not audible. Am I audible? Please raise your hand and confirm.
Yes,
Sir, you are audible.
Yeah, great.
Audible.
Thank you. So this is the idea behind econometrics. You combine economics and stats. Of course, maths is a part of stats is a part of maths. When we say stats, maths is always there. So when you combine economics, statistics, and mathematics together, you create something known as econometrics. There is a very good book, Arthur Goldberger. Okay, very classic book. It defines econometrics as a social science. See the word social science. Econometrics is considered a social science. It's not mathematical science or a statistical science, in which tools of economic theory, when we say economic theory, we assume sociology, management, everything in it. Your subject theory, mathematics, and statistics all come together to analyze what you are interested in. What are you interested in? You are interested in the y variable. You are interested in that y variable, whatever it is for you, whatever study you are doing, that y variable. So econometrics will help you combine your subject knowledge, maths, and stats, bring them together in a single equation, and then analyze it very, very scientifically. That's what econometrics is. It's a social science which helps you to deal with the fundamental problem. Remember that problem we talked about just now about causality in social sciences. In social sciences, we cannot do large scale randomized control trials or experiments. So what tool do we have to do those kind of experiments? We have econometrics. Okay, we can run different scenarios, see how different combination of x will affect y, and then take a call. What should we do? How should we change the x variables so that we get a y variable that we are looking for? All right, fine. Econometrics is a econometric models are very powerful way to answer real world questions. Shortly I will show you what are those questions. They put numbers on those questions and their answers. If I tell you, for example, that invest your hard-earned $1 million. Okay, somebody has $1 million amongst us. Great for you. If you have $1 million or 1 million rupees, 10 lakh rupees INR, and you invest that in this particular stock because it is going to go very high. If you are a scientific person, you won't accept that. You would ask, what do you mean by high? How high? What is that equation based on which you are predicting this? Show me the equation. I would like to know and judge it for myself. What's the logic? When I say equation, what's the logic behind it? Okay, don't explain me the technical equation, at least the logic, at least the X variables that you are using to predict that this share price is going to double in next 1 week. Okay, 100% jump in next 1 week. So what is there? So it quantifies, it puts a number. For example, if you know that increasing the salary will motivate your employees and they will do better work, the quality of work will improve, their work satisfaction will improve, but by how much? What's that number? You need those numbers because you're going to spend money. Businesses, individuals, governments, communities, they're going to spend money based on the solutions obtained from econometric equations, from empirical analysis. So if you are going to spend money, you need hard numbers to know exactly, when I spend this money, how much impact am I going to create on my Y variable. So if the company increases the salaries by 10% across the board, how much will employee productivity improve? By less than 10%, by 10%, by more than 10%? That's a question. It's a very, very real, concrete, practical question. Econometrics provides you that quantification. Who can use them? Everyone. Everyone who is from social sciences. Pure science people, they don't need econometrics. Why? Because they have experimental tool. They can experiment, control the things, know for sure what is going on with very less probability of error. However, in social sciences, we don't have that luxury. But everybody can use it. But who can create it? Only who is an econometrician. Okay. Only when you are trained in econometrics, you will be able to create econometric equations and estimate your whatever Y variable you are interested in. Fine. Some major types of econometric models are presented here. Okay. There are most popular ones are the single equation models where you have one equation. So you have Y, one Y is a function of say x1, x2, x3. The single equation. There can be many X variables, but the equation is one. So you are explaining something, your Y variable, only by one equation. So for example, there are three kinds of data you must have studied yesterday: cross-sectional, time series, panel. All right. So I have put questions on them. What kind of questions can these answer? See, the question is, how is the voting turnout? Okay, how many people have finally voted in your election? How has the voting turnout in the top 10 democratic countries in the world this year, 2024, is related with three X variables. So what is the Y variable? Voting turnout. What are the X variables? Popular sentiments, infrastructure quality of the country, and political campaigns. Political parties do a lot of campaigns. They spend lakhs of crores of rupees. They are not doing it just for fun. They know that by doing that, they will be able to create an impact on the ground and improve their voting turnout. So if you are asking this question for the top 10 countries only for this year, so the time dimension is fixed. That's a cross-sectional single equation model. Similarly, you take one cross-section. There were 10 countries: USA, UK, India, Brazil, China. Now you take China can't be in this calculation, sorry. Okay, we are looking at purely democratic countries. So if you take any one country, let's say USA, now you ask, how is the same question? How is the voting turnout in the USA for the last 10 years related with the same X variables: popular sentiments, infrastructure quality, political campaign? Now there is time series dimension. It's a time series single equation model. Okay, why? Because now there is only one cross sectional unit but many time elements. In the previous one, there were many cross sectional units, only one time element. You can bring all of them together into a panel. How is voting turnout in the top 10 nations for the last 10 years related with your three X variables: sentiments, infrastructure, and political campaign? All right. For each of these three, different kind of econometric equations and procedures are to be used. So you have to understand your data very well. Exactly what kind of data are you dealing with? Okay, you need to have very good understanding of that. Be very clear about it. Also, study literature to find out which kind of data is more suitable. Let's say in your area of study, lot of panel data are used. So you can think of using panel data, or you can think innovatively, let me use cross-sectional data or time series data and see how these dimensions work, how my Y variable behaves there, how the X variables, which are which are in the literature, how they affect my y variable if I use not a panel data, which is your popular one in your study, in your area, but time series data or cross-sectional data. That's also a new research dimension. Okay, using a new kind of data set is also a new research dimension. Somebody has asked some question about time series. At the end, I will answer you. Okay. Then there are multi-equation models where there is y is a function of x1, x2, x3. Then you also have x1, which is a function of x2, x3, and y. Okay, so you can have many such equations. What happens? From that single equation, you are taking one x and creating a new equation for that x also. So voting turnout is a function of popular sentiments, infrastructure, political campaign. Second equation in your study now is popular sentiment is a function of infrastructure, political campaigns, news, and voting turnout. So this becomes a multi-equation model because there are, for the same issue, that is how this voting turnout affected, you are creating equations for even for the x variables. So you are saying that I know how x variables are also determined, and I know that my x and y could be related to each other, affecting each other. But if the effect is not contemporary, that is in current period terms, immediately, then you can have multi-equation models. In the same case, if the effect is contemporaneous, by contemporaneous I mean immediate, that x and y together are determining each other. Okay, that together determining each other. You can't take out x separately and y separately and say x of x, y. They are constantly determining each other. Then you have simultaneous equation models. In simultaneous equation models, you allow your x and y variables to be determined together. In maths years ago, maybe you would have solved those 2-3 equations together simultaneously and found a solution. That's simultaneous equation model. So I hope you got some fair background on what are the different kinds of models that are used. This is very important. This is now what we are going to start in few minutes on our hands-on session. How do you do econometric modeling? What does it mean when we say do econometrics? Keep yourself muted. Nobody should unmute. If you want to ask anything, just put a message in the chat box. Later on, I will take it up. And we will have a question and answer round at the end. So what does it mean to do econometrics? These are the 8 major steps about econometrics. How do you do econometrics on the ground? As far as possible, try to follow this. In real world, you may not be able to follow it step by step. Some here adjustments have to be done, but stick to it on an average. Okay, on an average, stick to it. If you are working on, say, throughout your life on 10 or 15 or 20 high quality research papers, in most of the papers, you should try to follow this proper scientific procedure. You develop a theory. Okay, first you find out your y variable. Based on y, study the theory about that y variable, create a hypothesis, or you can create multiple hypotheses. Okay, whatever hypothesis you want. For example, salary will affect employee productivity positively. Okay, so that could be your hypothesis. And how did you find it? Through the theory. You did your literature review, you talked with people, you used your own common sense. Then you develop a mathematical model. How does it look? I'll show you tomorrow. Then you put in the random component, okay, the error component, and you get an econometric model. Your typical equation, y is a function of x1, x2, etc. You also add a e term, random error term, okay, error term. So then it becomes an econometric model. I'll show you just now how it looks. Then comes the data part. See, data has come so late. Try to understand. We have brought the data dimension so late. Up to from step 1 to 3, you don't need to bother about data. You need to sit down and do the background work. Then comes data, because if you have not identified the variables, how will you collect data? Isn't it? If you have not identified the variables, how will you collect data? So you need to identify the variables. Your y variable first, always y variable first. Then develop the theory, study the theory through literature review, experience, talk to experts, find out the x variables. Then you start collecting data. Now you look at the data sources. What kind of y variable measure, what kind of measures of x variable do I have? Now comes very important question. Start estimating the parameters. This is where actual econometrics is undertaken. Estimate the parameters of the model. What are these parameters? Regression coefficients, the coefficients of your model, econometric model. I'll show you in some time, don't worry. I'll show you actually concretely how it looks, and we'll estimate it also. Fine. Then you undertake hypothesis testing because you are generally dealing with sample. For example, you want to know how salary of employees affects. That's a very simple question. Okay, let's go on a more complicated question. The government of India is deciding, or your country's government is deciding, that by increasing the tax rate, okay, if we increase the tax rate, how will income inequality be affected? They want to study this. They need to create an econometric equation for this. They can't go on the ground, do an experiment, change the tax rate for the whole country, start collecting data. You can't do that without planning. You need to know what will happen on the ground. That is what responsible policymakers would do. So they will need to use data, past data. Now they will not have data on every person in the country. Fair enough? Or every firm, every company in the country. They'll take a sample data and they will start find out the y variable. They know the y variable, they know the x variable. Step 1, 2, 3 is known. Step 4 is now done. They have collected data on y and x variables. Step 5 is also done. They have put the equation, estimated the parameters, coefficients, regression coefficients. How much is the effect of x1 on y, coefficient 1? How much is the effect of x2 on y, coefficient 2? Okay, so they have the parameters also ready. Now you need to know whether these parameters which are from sample, are they strong enough, good enough to represent your population, which is the whole country. So you have sample of, let's say, 10,000 individuals and 10,000 companies in the country. But there are crores of individuals, millions of companies. So you want to use that estimated equations coefficient, which are based on sample data, and then answer the question for the whole population. Okay, whether increase in tax rate by 1% will increase income inequality, reduce in income inequality, or will have no effect on income inequality. You will find out a coefficient for your sample data, 10,000 individuals and 10,000 firms, companies. But you are not interested in those 10,000 companies and firms and individuals. You are interested in the whole country. So the step from that sample to population is hypothesis testing. Once it is done, once you feel after hypothesis testing that your coefficients are good, they are nice, they are how you expected them to be, great. Now start doing scenario analysis, start making inferences, start taking decisions what is to be done. So this is the broad idea or procedure how we follow econometric modeling. So when you do econometric modeling, you will have an econometric model. So what are the elements of that econometric model? It is presented here. Okay, there are two elements that I feel, this is my own way of looking at it, philosophical and technical. The philosophical elements are known to you. I have been discussing since point 1. Professor Shanmugan also discussed. Theory and experience will play a very important role. Many times theory is not enough, so your experience should also count. If you're working for many years in a big company or a small company, you know the supply chain very well, isn't it? You know the supply chain very well. You know how things work there. You know how goods move, how raw material moves, who are the middlemen, who are the players in between, how to negotiate with them. Experience. And you can also have knowledge of theory, how it should work, how the process must be working, what would be the equation, what would be the y variable and the x variables. So once this is clear, your what are these steps? Here they are step 1, 2 and 3. Okay, step 1, 2 and 3, that are philosophical elements. Once they are clear, you go on the technical ones, 4, 5, 6, 7, 8, etc. Okay, they include all this 6 major components. Okay, here I have explained those 6 components. We start with the identification problem, that is you need to identify that y variable. You know what is y variable. Let's say you are trying to study how voting turnout is affected by sentiments of people, political campaigns, and the infrastructure quality in the country or the region. You need to now find out a measure. How do you measure voting turnout? Do you use last elections voting turnout? Do you use voting turnout of last 5 years average of it? Do you use only last 3 years average? Or do you use a long run average of last 15 elections or 10 elections? That would be, say, In India, it would be around 50 years of data. Every 5 years, we have an election, central government, Lok Sabha election. So five elections would give you around 50 years of data. So how exactly are you going to identify it? You have found out, but how do you locate it, relate it, that theoretical y variable in your mind, in your idea, based on your theory, with the real world, data? Because real world may not give you the kind of data you need. Like in economics, everybody talks about taste, preference, satisfaction, utility. Now we can't measure utility in the real world. All we see is buying preference, what people buy. For example, demand and supply. Has anyone amongst you till date seen demand and supply in front of you going on? When you look at data, there's sales data. Companies report sales data. Very important. I and my long-time student, Mr. Lucky Pandey, who is now sitting in Ministry of Health and Family Welfare in Delhi, is going to take a session of yours on big data. We had written a very elementary basic paper many years ago. It's not published in a great journal, but if you read that paper, the idea is very interesting. Sales cannot be considered as demand and supply. It's both simultaneous, the equilibrium value. So in reality, you observe sales data, but you want to create a demand equation or a supply equation. So identification is that challenge. You know what is theoretically required, what is your variable, how it should be defined, but the real world may not be friendly to you. So which kind of variable should you use? How should you measure voting turnout? Last 3 years, only central elections, okay, national level elections, or you should also take into account regional, state level election data, voting turnout also, and bring them together. That's the identification problem. Same applies to X variables. Sentiments. What do you mean by sentiments? Okay, how do you measure sentiment in the real world? Identified sentiments. Theoretically, it is sentiment that affects voting turnout. In practical real world, where is that data source? Locating that data and ensuring it is as close as possible to your theoretical idea, that's identification. Then the next two are known to you. Okay, next three are known to you. Dependent variable, y. The independent variable, all right, the x variables, and the relationship, function relationship, the form of the equation. There are many different forms of equation. You can write equation in thousands of different forms. Okay, so what is the correct form of equation you should use? How should X variables be included? Like yesterday, one very good question came from one candidate. She contacted me after the workshop. She said that I have variables which are measured in different measurement units. Some are in percentage, some are in actual level form, in currency form, some are in growth rate, or some are in first difference. So what should I do? Should I bring them together in one single equation? Yeah, you can bring them together. What's the problem? That's your functional relationship. See, variables are different. They will behave differently. You need to allow those differences. You can't bring variables on the same platform. Okay, that's not correct. Because when you do all those manipulations, you are taking away information from the data. You are stripping away information, throwing out information. It's like you have fresh fruit in front of you and you peel its skin cover, and then chop it off, then bake it, and then deep fry it, and then you create something out of it. You don't need to do that. Enjoy the fruit as it is. Different fruits are going to have different shapes, different texture. Similarly, different variables will have different measurement units. But you need to ensure that if they are time series data, they are stationary. That is what I discussed with her. And some other properties are there. Dr. Harsh Rai will talk about it. Okay. Finally comes the stochastic element, that is the random error. You know that voting turnout is a function of why voting turnout is a function of or affected by sentiments, infrastructure, and campaign. But are you 100% sure these are the only three factors? Absolutely no. Like salary will affect productivity of employees. Yes, it should, it will. Are you 100% sure that only salary will affect productivity? You may increase the salary, still people may not be productive. Why? Because toxic work culture is there. You are seeing in the news, what happened with Anna Sebastian, a 26-year-old chartered accountant who died because of heart stroke. Two people, I would not take name of the companies, it is being recorded by JKEA, but two people from the financial services sector, from two big players in the financial services industry, they committed suicide. They literally killed themselves. The reason for doing that was, the reason for doing that was extreme work pressure. Extreme work pressure. So, if you keep increasing the salary, are they going to be happy? No, there are other factors also. You are focusing only on salary, but in reality, there are other things also. That stochastic element takes care of that. This is where econometrics deals with all the problems. How do you ensure that stochastic element is as balanced out, as random as possible? When we say something is random, there is nothing systematic in it. There is no useful information in it. So econometrics deals with this. It tries to create equations where this stochastic element is as random as possible to ensure that we have a random error, and so that whatever x variables we have, they will explain your y variable. There will be some other x variables which you don't know about, but on an average, they will not have any great impact on y because they are random in nature. Okay, they are random in nature. Something, if it is random, you can't control it, let it be. But whatever is not random, I know that. I have included that in my equation. That is your purpose of doing literature review, knowing the theory. Identify those x variables. After knowing your y variable, you identify those x variables well. You need to ensure that whatever is left out, that residual, that stochastic element, is not systematic, it is random. By random, we mean there is nothing great in it. On an average, it will not have any impact. On an average, its impact on y will be 0. So we are safe. So we are absolutely safe. No need to worry about it. If it is not random, if it is systematic, showing a pattern, that means you are not taking into account all the x variables. Right? And tomorrow session will primarily focus on the last element, this estimators. How do you estimate? What's the formula recipe behind the equations? In equations, there are coefficients like voting turnout. Y is a function of sentiments, infrastructure, political campaign. Now, sentiment will have some impact on voting turnout. That's the first coefficient. Infrastructure will have some effect on voting turnout, second coefficient. Those coefficients are calculated using an estimator, a formula. Okay, a formula. The debate in econometrics is to find out the correct formula. And I keep saying that OLS remains the most powerful, the best way of handling most of the kind of problems you will deal with. Only when those conditions are not fulfilled, like autocorrelation in time series data, heteroscedasticity in cross-sectional data, those things, when they are not followed, those assumptions, those requirements are not followed, only then you start looking at something else. Even in those situations, OLS will do much better than many of the other estimators, that is formulas or recipes. How do you calculate those coefficients? Some formula is required. Using your sample data on your y and actual y that you observe and your various x variables, you need that formula. I've sent you an Excel file. You use that and you find out the coefficients. But what formula to use? How to bring those x and y data together? OLS is the best formula. OLS is the best way to do it because its properties over large samples, even in small samples, are very good. Even when they are violated, it can still perform much better than many other estimators. But yes, when you feel that there is some fundamental problem in data, like very high multicollinearity, your x variables are madly correlated with each other, then you will not be able to use OLS. And that time you take a new technique, new equation, new formula. For example, I have used in my Routledge book ridge regression also. Ridge regression, ridge estimators are estimators that handle the problem of multicollinearity. They put penalty for multicollinearity. But unless those kind of problems are there, no need to run behind sophisticated and new kinds of techniques just to feel good. There is no need of that. Stick with OLS. All right. You should have very strong reason why you are keeping OLS aside. Like in my recent work, I have used logistic regression. Why did I use that? Because my dependent variable was such that OLS will never give me efficient results. So you need to have that reason behind it. Why OLS is the gold standard in econometrics. It is from where everything starts. Unless and otherwise any of the assumptions are violated, it remains at the top. Only when some of the assumptions are violated, it goes lower, and some other estimator or econometric technique, when you say technique, it's basically estimator that comes on the top. Fine. So this is how an equation would look like. Y is a function of x1, x your independent variables. For each x, there will be a coefficient called beta. The beta is shown here. And of course, you cannot be overconfident. You can't assume that your x, all your x, whatever they are, 5, 10, 15, 20x, they will never be sufficient to explain your y. So you depend on the error component. That is, you allow some other factors also to play a role. All right. Don't look at these equations. I'm not going to cover it. It's from my Routledge book. I will take a different work. But what it explains is it's a functional form. See, look at the functional form. They are in logarithmics, natural logs. Y, A, L, X, A, L, and X are my X variables, X1, X2, X3. And Y is my Y variable. They are in logarithmic forms. Okay. It's a functional form of the equation that I have estimated. Similarly, there is another functional form that I have estimated. You can see that non-linear functional form. Okay, where I have x1, x2, x1 square, x2 square, and then I have x1 multiplied by x2 here in L into in K, labor and capital. So how did I find this equation? I firstly found out what's my y variable. Okay, what variable am I interested in? Then I did my detailed literature review, talked with people who have worked in this area, discussed with them, used my own common sense, and then I framed this should be the x variables for my study. Achha, how did I know that I should have second functional form, this non-linear functional form? Again, through literature review, through my study, through interaction with experts, you come to know about it. This is the estimated regression. We will estimate another regression right now in the hands-on session. But this is our typical estimated regression looked like in my case. Okay, and you can see the coefficients are very large. That was the reason why this is OLS based. Yeah, Arshi, I'll take your questions later. I'll definitely take your questions later. So if you see the model 1, there are so large coefficients. I mean, madly large. This is one practical concrete case study why OLS will not be suitable in this. In my data, because I'm using x1 labor, x2 capital, x1 square, x2 square, capital square, and x1 into x2, there will be very high collinearity amongst my variables. These are time series data. So what I did, so what happens is you see the size of the OLS coefficients. So large, phenomenally large. That is why I had to use ridge regression. Okay, model 2 is the ridge regression that I have used. I have explained in my notes also. And now you see the coefficients are much more realistic, much more within the limits that theory says they should be. If you increase labor by, if you appoint one more person and your output increases by 10,000 times, it's very abnormal. You can't expect that, But now in model 2, it becomes much more clear and much more realistic. So I decided to use OLS to show the results, and then also use ridge regression, because OLS is not suitable when you have multicollinearity. So whenever those fundamental assumptions are violated, what are those assumptions? The classical linear regression model, which we are going to study tomorrow. When those assumptions are violated, only then OLS becomes less good. It doesn't become worst or bad. It becomes less good. Still, you can handle OLS. Even if there are some issues, you can still go on with OLS. Okay. We'll talk about that tomorrow. Okay. We'll talk about that tomorrow. Let me move ahead. So some practical uses of econometric models before we go on our hands-on. Okay. Some practical uses of econometrics, some questions, practical questions in different subjects I have put in front of you. In economics, a very popular question, for economists, or those who are working in industrial economics, firm economics. Does having minimum wage help workers? Fair enough. Very, very rational question. If you have minimum wages, Balaram Raula, please stop annotating and drawing lines on the screen. Please remove it. Okay, so minimum wages. If you fix wage at some minimum level and you say every worker is guaranteed that, will it really help the worker? That's a question. You need to do econometric modeling. Similarly, HR management. How do you reduce attrition in the gig economy? Balaram Raula, I am again requesting you, don't annotate and draw lines around. It is disturbing everybody. Please don't do it. Please maintain discipline of the workshop. IT team, if this person continues, please request them to leave the.
Yes, I can. Let me remove him. He is repeating.
He's repeating. Yeah, please remove him if that is the case. We need to have very strong discipline. We all are having so much of work, and yet we want to do serious work here. That is the philosophy of JKEA and ours, that we want to do serious work. You can see how much time is required to prepare these things. So let's maintain that decorum. So in HR management, what's the practical question? How to reduce attrition in the gig economy? Gig economy is your seasonal, unstable economies like Swiggy work, Zomato work. Those kind of works are part of gig economy. How do you reduce attrition? How can Swiggy reduce the frequency with which their delivery executives are leaving and new ones are joining? Because that's costly for the company. They have to keep training new people constantly. Then in marketing management, we have a very popular question. Why do people buy masstige products? Those who are from management and marketing will know very well what are masstige products. Those products having mass prestige. They are affordable yet luxurious, perceived to be luxurious. Now, why do people buy such kind of products? This question requires an econometric model. In sociology, how can gender discrimination can be linked with patriarchy? So that the idea of male dominance, that males are superior in things than women, wherever it is, in many societies it is still prevalent. How does it affect gender discrimination? That thought, that idea, or that perception, that ideology, mentality, how does it affect discrimination against women, for example? But there can be other genders also, like transgenders. How are they discriminated? So you can answer those kind of questions using econometric models. I'm telling you real world applications. There is literature on this. You contact me after this, I will give you large amount of literature that is using econometrics to answer these questions. Okay. Then in political science, why do voters vote differently in local elections versus in national level elections? That's a very many times we see some parties winning in regional elections, but they are not able to crack it at the national level. So what's the difference there? What's the factor? What are the factors behind it? In accounting, very popular question, what is the true value of a company? What is, those who are from accounts here will be able to easily connect. Very big question, very philosophical question. There are value theories, fundamentalists, there are technical analysis, and there are all kind of schools of thoughts. What is the true value of a company? Is it what is seen in the stock market, or is it for what is seen from the accounting books, or both, or something else? In military science, military science, very important. If you're planning for a war, let's say Russia Ukraine war is going on, and one country is planning to initiate an attack on the other one, how would they minimize the civilian casualties, civilian damages in this? They need econometric model for that. Such a fascinating area of application. See, it's something bad. We should not have wars. We should never have wars. Peace is the ultimate answer. Diplomacy is the answer. Look at India, for example. It has been able to manage all of its or most of its issues through diplomacy. By diplomacy, we mean negotiation with the other people, other sides. Diplomacy is the way to deal. But if it is going to happen, if it is inevitable, how do you minimize the damage to people, to properties? You need econometric model for that. Investments. What is the best way that you can maximize your returns? If you're investing in various mutual funds, in stocks, in gold, in property, wherever you are investing in, how do you create that optimal basket so that your returns are maximized? All these questions have a lot of literature where econometrics is used. Friends, all these questions have a lot of literature where econometrics has been used. Okay, now we move on to our hands-on session. Okay, and I hope till now you all were clear whatever I have discussed. This is the foundation, fundamentals of empirical methods and empirical analysis. It is very important to be serious about these things before you start doing your data work. Otherwise, you will fall into the trap of data mining or reverse causality. I mean, you will prove something before proving it. So then your analysis will be of no use. We'll start with our data set. I'll just open another screen and share the data set screen with you all. All right, I'll share the data set screen with all of you. I am assuming by now you have been able to install Gretl. If not, I'll let you know later on what to do. But this session is being recorded, so you will know the steps here also, and later on you can revise it. So let me share the what do we say, our Excel sheet screen, okay, which I've shared. So please open it. Those who are going to do live hands-on with me, open that Excel file that I have shared with you. I am also opening at my end. All right, I am also opening that Excel file at my end. Now I will share the Excel screen with all of you. The Excel screen has been shared, and I'm sure now you should be able to see the Excel screen. There are two sheets in the Excel screen. Okay, the student performance quant, that is quantitative data, and then there is one more which is a larger one, which has qualitative data also. But I am not taking that right now. It's not a big issue to take it up, but it will make the session too long. I mean, if you're ready to sit till 10 o'clock, I have no problem. I'll sit and continue doing it. But if you want to understand the basics, how Gretl works, the aim of hands-on is to teach you what we have discussed on a new software, on a new technology. So I think the first data set is enough. The first sheet, student performance quant. So all the data are quantitative in nature. Okay. So the data are for a problem where somebody wanted to analyze how student performance is affected by what determines student performance. Okay, what determines student performance. So let me go back to my presentation screen. I have written something really interesting regarding this problem. Very important to discuss about that, you know, before we start. So this is the conceptual framework within which we are going to analyze. Okay, what are the research questions we can try to answer with the same data set that I have shared? The same data set that I have shared, you can ask at least 4 questions that I have identified. First is, what determines the performance of students in exam? Very important question. Okay? As a college, as a university, or as a policymaker who sits in education department, you need to understand what is affecting the performance of the students in your area, in your country, in your region, in your institute, whatever it is. Second question I can ask for the same data, kind of data, forget the data. The second question I can ask is, how can I improve the performance of my students? The first one is an explanation question. You need to explain something. The second one is a prediction question. You want to create a model, an econometric equation that can help you to predict how well your students will perform if you make certain changes in your X variables. Okay. Third question, why do some students perform better than others in exam? That's also a question. Why do some students are seen doing better? Say, for example, overall or in some subjects compared to others, while you are giving the same input to all of them. As a teacher, I'm teaching them the same thing during the same hours, taking extra classes, doing revisions, doubt solving, yet the outcomes are different for them. Finally, how can exams be managed to help improve performance of the students? So we don't want to pressurize the students, create a pressure cooker for them. You know, we don't want to make exam a hellish experience. We want to improve their performance in a manageable manner. Okay, so how can exams be managed so that students' performance is improved? You may reduce the number of exams, increase the number of exams by making them shorter, do something, you know, evaluation question. For all these questions, the same data set is enough to answer. So the question, what is the dependent variable in this? If you can write in the chat box, what is the dependent variable now in our hands-on session in the data that I have shared with you? Okay, let me go back to the data again. This is the data that we have. I've just reshared the Excel screen. Now, in this Excel screen, which one is the dependent variable? You may type in the chat box. Very good. Performance of the students, correct. So how do you measure performance of the student? See, performance of the student is your theoretical variable. Why? Identification says you need to convert it into a real world measure, so which is your exam score. Yeah, performance is correct. How do you practically measure it with the data that you have? Exam score. Very good. Performance is also correct and exam score is also correct. Okay, exam score, excellent. So some are saying marks. So yeah, exam score. Here the word uses exam score. Now the question comes, what's the theory? Your theory problem is to study exam score, your y variable. But what explains y variable? What's the theory behind it? If you investigate the literature, you talk to various experts, teachers, professors, evaluators, you will come to know that there are some variables which are common to whatever they are saying. There are some solid common variables. They are always talked about in the literature. The number of hours students are studying, okay? Number of hours that students are studying. Their attendance in the class, very important. If they are not participating in the teaching learning process, how will they learn? All right. Then their sleep hours, how many hours they are spending on taking rest, because when you rest, there is a theory behind it. Okay, how each of this x variable affects y. There's a theory. If you sleep well, the logic is your brain is able to settle down all the information, whatever you have studied, create neural networks, neural connections, and you are able to grasp the information, retain it for long term. Then previous scores, that's also very important. If you're scoring well till now, chances are you will score well again. Okay, if you're scoring well till now, chances are, unless it's a competitive exam, see, very important, you should know what kind of exam you're talking about here. The typical academic exam we are talking about. If competitive exams, it can be very different. If you're constantly scoring well, I believe your chance of scoring well in the next exam will fall down, because competitive exams, what they do is they keep changing the pattern of questions and make it very random. Many of the JEE, GATE exam, even UGC NET exam, then very international exams are there. Let me have water, huh? Just a moment. So then the previous scores will have an impact on the current exam score that you are looking at. Okay, how many hours they were being taught or they attended the lectures? Okay, or you can this variable represents how many hours they were given extra tutoring over and above the regular lectures. Okay, each of the student, how many hours they attended extra classes. So this student has not attended any extra class. Just yeah, this student has not attended any extra class, meaning they don't feel the need to go for extra sessions. They are satisfied and able to understand during the regular sessions. This student has attended for 2 hours. That's the logic. And lastly, we have physical activity. Very important. Sleep improves your mental health, but physical activity will improve your physical health. When you are fit, healthy, your body is working well, you will be able to handle the exam stress, study stress, put longer hours, sit down for longer hours. You know? So those factors are very important. So it's very easy to understand now. What's the conceptual framework we have? In our conceptual framework, y variable is the exam score and x variables are hours studied, attendance, sleep hours, previous score, and tutoring session and physical activity. For how many students? We have data for 6,607 students with us. How did I get this data? Actual data set collected in US. It is available on Kaggle, Kaggle. It's an open source data platform where a lot of data sets are available for machine learning and other basic statistical analysis also. So I'll share that link also. There are so many different data sets. Okay, fine. What we need to do now is we need to take this Excel file to Gretl. So what I'll do is now I'll open Gretl in my computer. I'm launching Gretl and sharing a new screen with all of you. Yeah, you can now see the screen. Correct. I kept the screen small. I'll maximize it also. You can see the screen in front of you. Let me maximize it. Now you can see the Gretl screen. Yeah, Minhaj Akhtar has raised a very good question. Isn't there multicollinearity between study hours and sleep hours? Yeah, there can be multicollinearity, but we need to test it and we need to see. Theoretically, there can be. Okay, how many hours you are studying and how many hours, because total number of hours are fixed. So if you are doing something more, other could get affected. But it's possible that in between the gap between them may be utilized differently. So these two things might not have multicollinearity, or it might have multicollinearity, but it may not be severe enough to create any trouble for you. So when we load the data, we can check it. When we estimate, we can check it. I'll show you. Good question. So we have this. Gretl window in front of us. You have the option of file, correct? In file, what we do is we go on the option of open data. Those who are with me on hands-on, who are ready and live with their Gretl, open your Gretl software window, keep it, launch it. You'll see the main screen that you can see here, and in this main screen, you have to press the file option, top left. Okay, just a moment. Yeah, top left. You have to press the file option, and we go to the option open data, visible in front of you. File option, open data, and you go for user file. Okay, user file. And now what I'll do is I'll locate the file where I have stored it. I will locate the file wherever I have stored it, and from that file, now I can't see that Excel file. When I open that folder, I don't see the Excel file, because by default it tries to find out, or by default it tries to search for Gretl files, whose file extension is .gdt. So you go here and you go on the bottom one and you select all files. So now everything is available. Okay, just now my file is not here. My file is here. Just a moment. Yep, here. So now I have this Excel file visible. Okay, 15/10/2024 Dr. Bhagirath session file, which I have shared with you. I'll press open. I've selected that file and now I'm pressing open on it. Once I press open, somebody is asking to repeat the option. Just a moment, let me load it. So once I open, if there is only one sheet, it will directly bring it in the Gretl environment. If there are more than one sheet, it will ask you which sheet do you want to work with. So we want to work with the first one. Okay, the student performance underscore quant. So I'm canceling it, and I'm again showing the steps, okay, of opening the file. Harpreet Kaur, I am again showing the step. Pay attention, please. File, you have the Gretl window ready. Go on the option file. Go on the option open data, first one. Go on the option user file. Now, wherever you have located the file, go in the directory and folder first. Okay, whenever you go there, you won't see anything. Perhaps you will only see the folders. Why? Because by default, Gretl looks for Gretl data files only. So click on that option. Go for the option all files. Once you do that, you will see all kind of files, PPT, PDF, etc. You can't import them. You can only import CSV files, data files, and Excel files. So you go on this Excel file, which I am interested in. You also must be having the same file in your computer. Press on open. Once you press open, it will ask that there are multiple sheets. Which sheet are you interested in? So I am interested in first one, not the second one, but the first one. We press OK. Yeah. Once you press OK, it imports the Excel data, reads it in the Gretl language, and opens it and prepares it for you. It asks you a very important question. The imported data, that is Excel data, are interpreted as cross-sectional. It has identified, looking at the data, that it is cross-sectional data, which is correct. The data is cross-sectional. It is fixed at a point in time. There is no time series dimension. Okay, so data is cross-sectional. Do you want to give the data time series or panel interpretation? Of course not. We don't have that. Sometimes it may not be able to read in rare cases when you are dealing with panel data. Even if there is a small problem mistake in your Excel sheet panel file, it may read it as cross-sectional data or pool data. So at that time, some problems can occur. But otherwise, it won't occur. So you will go for the option no. So you are agreeing with Gretl. Now we have constant here, which is by default always there. Okay, the constant element in a regression equation, which we will discuss tomorrow also. And I'm sure by now you understand that x1, x2, x3 are there, but there is one constant put in every equation. What do we mean? Even if all the x variables were 0, still that y variable will have some value. For example, your food consumption, how much food you eat every month as a family. if your income falls down to 0, let's say you are analyzing food consumption, y is a function of income, x. Even if your income becomes 0, your food consumption will not become 0. It will be some positive number. You will borrow from people, you will use your savings, you will buy on credit. Eating is something you need to do. So that's the constant term. Then we have our variables, exam score, hours studied, attendance, correct? And the way in which you have put your variables in the Excel sheet, whichever variable, each column is a variable in Excel sheet. Whichever variable comes first will also come first here by default. It will get this ID as per the Excel sheet. So what I do is whenever I want to estimate something, I create an Excel sheet and I keep the dependent variable first, y variable. Here I also kept student variable. It's just the number of student. It was just for you to recognize. It's of no use. We can delete it also. I'm deleting it. All right. You can also delete it. There is no need to have. Right click on that variable, student variable, press delete, press OK, or yes, it is done. So we have exam score first, correct? We have exam scores first, which is our y variable, dependent variable. And we want to explain the exam scores with all other variables, which are our 6x variables. Hours studied, attendance, sleep, previous score, tutoring session, physical activity. All right. This is what we have with us. And we have gone through the Excel file. We know what these numbers are. We know the logic behind them. Now, I am not using time series data deliberately because in time series data, there are a lot of other things to be done. You need to graph them, visualize them, go for structural break and stationarity. And then there are issues. If you have both non-stationarity and structural break, then you need to do more advanced tests. So I do not want to get into all that. I have left it for Dr. Harsh Sahai to handle. He will handle everything. Okay. So I am going to take up only. I'm sorry to Harsh if he's live, but I have left it for him to handle. So there's too much of content to be discussed in that. So I have not taken it up. So I have taken cross-sectional data. Now, what would we like to do? By now we understand that our y variable is exam score, x variables are all these. We know that, but that doesn't mean we simply jump onto estimation work. All right. We would like to firstly see what is the correlation of these variables among themselves. Amongst themselves, what is their correlation? Are they very strongly correlated amongst themselves? Then that multicollinearity issue can arise. Are they correlated, but correlation is quite less manageable? So fine, we can go ahead. There is no correlation. In that case, fine. Still, there is very good scope for causality to be there. All right, it can be there. Not necessarily it will be there. Even if correlation is not there, causality could be there. But if causality is not there, correlation is of no use, even if it is there. For example, that my sleeping hours and the stock market, if they are positively correlated, government is not going to ask me to sleep every day 24 hours. The stock market goes up, or an investor will ask me, Bhagirath, I'll pay you as much money as you want. You just sleep, don't do anything. You'll get lakhs of rupees every month. Just sleep. Causality is not there, so that correlation is of no use. Just throw it in there as well. Causality comes from your theory. What is y, what is x, how x would affect y. That comes from a theory, a review of literature, experience, talking with experts, rules of thumbs, etc. Okay, so what we go on. First of all, look at this option of tools. Look at this option of tools. Lot of things that you did yesterday with Dr. Parmit's session can be conducted here, which you did in Excel. Our aim of introducing Excel was that most of the softwares, they don't have the capability of spreadsheet. They can't record data and help you create data set. Excel does that. So you need to be good with Excel. But you can do a lot of that analysis here also in the tools option. You can go for example, test statistic calculator. And yesterday, I'll have to again share the screen. I'll share another screen with you, test statistic calculator. How did I open it? Let me show you. Okay, let me show you and share the Gretl screen with you again. Gretl screen, go to the option top left, go to the option tools. Once you select the option tools, go to the option test statistic calculator. Once you press it, a new window will open. Now I'm sharing that window with you. Now just see the capability of Gretl. Absolutely brilliant. It will take data that you have fed in, start doing the tests for you. You can choose what kind of test you want. You can specify its parameters, okay, the moments of the distribution that you are interested in. You can go for a mean test, that is, you can see whether the mean value of your variable of interest is statistically different than certain value that interest you are interested in. Generally it is 0 popularly, but in your problem it can be anything. It can be 5, 10, 15, whatever you are interested in. You can do that test. Various options are there. I'll not get into all those options. Then we have variance test. You can look at variance whether it is statistically significantly different than the number that you are interested in, your null hypothesis. You can go for proportion test if there is some proportion variable in your data. More popular ones are two means test. Two variables, are their means statistically different than each other? Are their mean, for example, sales in let's say North India of a particular company, are they statistically different than sales in South India? If they are, that means your marketing campaign has to be different. The marketing process has to be different. The underlying equations are different. If they are not statistically different, you can use the same marketing campaign in both North and South markets. I'm telling you a practical application of these tests. There are a lot of thousands of such applications. Very simple, very basic for you to understand. Same variances and proportions. So all those capabilities are there. All right, now I'll share you again Gretl screen. Same screen that we were interested in. Now what we want to see is, yeah, there are various tools available. There is command log also. So Gretl allows you command language. Once you go for the command log, Gretl will allow you command language like any sophisticated software that you know, Stata, R, JMulti, whatever it is, Python. This is not as great as Python. Mr. Dwarkesh will teach you Python, introduce you to Python, not teach you. He will show you how to work with, initially work with Python. So you can have command language here also, but no need to do that. The beauty of Gretl is it is very user friendly. There are all the options are available. Unless you are going to do very advanced things, you don't need to worry about command language. That's the beauty of Gretl. So anybody can learn it. Anybody can get hold of it. In Gretl, there is a help option. If you go on help, top right side, help option is there. In help, you will have command reference. If you are going to use command language, each command is explained how to use it. Various functions are there in Gretl. Packages are there in Gretl. These packages are basically add-ons, more advanced versions of something that you want to install. Gretl is a base software, basic version. You can add more add-ons to do more advanced modeling like structural var, which I've been using, or time varying var, or you can go for something like Bayesian var, so Bayesian modeling, state space models. You can go for qualitative econometric model that is inbuilt in this. Many of the things are inbuilt. So something which is not inbuilt in Gretl can be downloaded and installed in the Gretl package as an add-on extension. So if you look at this option, check for add-on, you will see the various add-ons that I have already installed in my computer, in my Gretl. These are all the add-ons that I have in my computer. You can go for, you can find various add-ons by looking at updates. There is so much of option in Gretl, and you can go through its official website also. They have a separate page for add-ons, whatever latest add-ons are available, and you can download them. They are files, extensions of this file. They will introduce new capability. Now, why is dataset structure important? Once you tell Gretl that this is cross-sectional or time series or panel, if you go to this option variable, if you go to this option variable, this option variable, you will see that certain things are disabled. So what Gretl does it automatically disables the options which are not relevant for the kind of data you are dealing with. So you need to be very clear about the data you are dealing with, and you should be careful in specifying the correct type of data. Otherwise, you will end up doing very silly and problematic mistakes. Fine. Then you have the option of sample. Here you can restrict your sample. For example, you can set a range that I want sample only from this to this and remove others, truncated sample. So you want to only analyze students in this case whose exam scores were above 75. So you remove all other students. So those kind of arguments can be put here. It's up to you what kind of analysis you want to do. I don't want to do any such truncation. I want the full sample with me. All right. Then in option add, you can add different forms of the variables like standardized variables. Like I'll select, I'm pressing on any one variable, and then you can press control plus A, control A. After control, just press A. It will select everything, all. Then you go on add and go on add option, press on the add standardize variables. It will ask you whether divide by sample standard deviation or with sample standard deviation without degree of freedom correction or center it only. It's up to you how you want to standardize. Standardization itself is a area of debate, but in general there are rules of thumbs, okay, where we standardize through sample standard deviation itself. So now it is standardized. Why have we standardized this? Because the measurement units are different. Okay, so yeah, that person who was asking whether if my measurement units are different, indices, percentage, rupees, etc., what would I do? You can go ahead and do the analysis. You can estimate your equations, but you won't be able to compare the coefficients. That will be a problem. But if you standardize them, the results will come the same, but you will be able to compare the coefficients. Which coefficient is having, which x is having larger effect on y, x1 or x2 or x3. If you standardize them, which option I have shown you just now, control A, select all variables, go to the option add, standardize, and select the option divide by sample standard deviation. Then you will have other set of variables which are standardized, and here you will be able to compare the regression coefficients after estimating them, the equation, econometric equation. All right, so let's look at correlation matrix. Okay, we want to see how the variables are correlated. Go to the option top mein view. In that view option, no need to select any variable, it will give you the option to select variables. Go to the option view, select the option correlation matrix. Now select the variables we are interested in. We are not interested in correlation between standardized variables. We want the level form variables, not the standardized variables. There is an option uniform sample size. If there are some missing data or something like that, it will chop off those observations. Otherwise, it will, for each variable, it will take as many observations as are available. Okay, so generally the correct idea is to ensure uniform sample size so that your comparison becomes manageable and more reliable, particularly in time series data. In time series data, if one variable is lengthier than the other variable, that lengthier variable may dominate the correlation, is it? So there are some practical tips I'm giving you. After doing that, press OK. Once you press OK, okay, I'll share that screen with you. What after pressing OK, something will come. I'm sharing the screen. This is the correlation matrix that will come in front of you. All right, you can see the correlation matrix. No need to worry about the correlation tests given here that you can study and later and understand, or maybe we can discuss tomorrow. But understand how Gretl is communicating with you, interacting with you. Your variable exam score is here, and in the row side and also in the column side, exam score is here. Naturally, any variable will have perfect positive correlation with itself. All right, so it is 1 here, ignore that. You have to ignore all the diagonals. All the diagonals are to be ignored. Okay, all the diagonals to be ignored. They are correlations of the variables with themselves. Now, what is the correlation of exam score with, say, sleep hours? It is showing a negative sign here. Okay, it's slightly negative, not very, it's quite near zero, but negative. For attendance, it is positive. Okay, and with our study also, it's fairly positive. Remember, this is cross-sectional data. In cross-sectional data, the range of accepted strength of correlation differs. In time series data, if you have not stationarized the data, correlations will look very high, 0.8, 0.7, 0.9, 0.98, 0.99. But in cross-sectional data, having a correlation of 0.44 is a, and that too positive, is a good sign. I mean, this correlation is not very high, and yet it is a meaningful correlation. So exam score is having a positive correlation with our study. Yet you understand, we don't know whether exam score is causing our study or our study will cause exam score. You are identifying it through your understanding of theory, that exam score is determines y variable. It will be determined by our study. It could be other way around also. If you're scoring well in exam, you may be motivated to keep studying more. I mean, I'm not saying that's the truth, but correlation does not imply causation. You have to be very careful. So how do you find out causality? Through theory. Don't estimate it. Don't do that mistake. Don't estimate exam score on our study and then quietly our study on exam score, whichever it is significant or more significant or looks better, that's how it is. Oh, no, no, never do that. Be unapologetic about your theory. If your theory says something, specify it in advance before presenting your results. Show your result exactly as per what you expected in theory. If they are different, show it to people. That's also finding that your theory is not directly suitable or not being represented by this kind of data that you are dealing with. Something else might be going on. So then in management theory, perhaps we have this mediating and moderating variables. Structural equation modeling is used. Mediating and moderating variables are brought. So in exam score and our study, some other variable is brought. For example, here between sleep hour and exam score, correlation is very low. Negative, but it's very low. It's almost near zero. So you might be tempted to assume that there is no correlation, but there may be a mediating or moderating variable, which when controlled for or brought into the picture, will improve the correlation between them. So these are the questions whose answer will come only from theory. That is your subject knowledge, your subject, whatever subject, issue, topic you are working on. Do the literature review well, go in depth, spend time on the literature review, talk to the experts who have worked in that, use your own understanding, common sense and experience also. Fine, this is how correlation estimates can be found out, correlation matrix can be found out. If you want to copy paste it, just press Ctrl A, right click, okay, Ctrl A, right click, press the button copy. It will give you three options: RTF, plain text, latex. Generally I go for RTF. You press OK, go to Word file, press paste, and it will paste it as a blank table without any borders. So then you have to convert it into a table, or you can take this directly to Excel also and paste it in Excel. And you will have to do minor adjustments here and there, but you can create a very good Excel table there. Because most of our research work, we don't use direct outputs from softwares. We have to go to Excel, systematize it, properly organize it, then report it. There is some other option, one other option called heat map. Wonderful option for you, those who are working on correlation analytics, wonderful option for you to see the heat map. The diagonals are to be ignored, as you know, in the heat map. You don't need to work with diagonals. And the other ones, so this gives you a very good visualization of how your variables are related. Dr. Malik, 10 minutes more, then I will be ending and we can have Q&A.
Yes, please go ahead.
Yeah. So this is a wonderful way of visualizing your correlation data, how your variables related. And how would you go with this? You look at that's heat map, and you of course ignore all this. This is of no use. Okay. But this one, this, and this one, these are all important areas of investigation. You should investigate it. You should, for example, exam score. See, you are interested, your Y variable is exam score. This entire first one is for exam score. At the bottom here, it is written exam score. So you are interested in the exam score option, correct? Just a moment. Let me bring it properly in this window, like this. Yeah. You are interested in exam score here at the bottom. And these are all variables showing their correlation with exam score. So tutoring session, previous scores have mild correlation with exam score, which is quite decent, being it is cross-sectional data and it is 0.2 for such a large data set. Large in traditional sense, not in big data sense. In big data sense, it is very small. For attendance, much stronger correlation. So attendance must be playing a good amount of role here. Okay. By what are we assuming? We are assuming that that all these variables here are x variables and exam score is the y variable. There is no way that exam score can affect this. And with regards to attendance, of course, attendance is taken first, exam is taken after that, and score comes after that. So even from the time logic, attendance comes first. So you are fine with this logic. So it's a good development. Attendance has a quite high correlation, 0.6. Our study also has a positive correlation, and it is 0.4. Sleep hours has almost no correlation. Physical activity is showing no correlation. Does it mean that you should not include it in your regression model? If the correlation is low with one of your x variables, with your y variable, does it mean you drop it from your regression model? No. It only means from a correlation perspective, it is not strong. When you control for other variables, which is what regression does, it controls the effect of x2, x3, x4, x5, everything when looking at effect of x1 on y. Similarly, when you're looking at effect of x2 on y, it controls for x1, x3, x4, x5, everything. When you do that, the scene may change, the situation may drastically change. All right. Acha, now there are some problem areas. Like somebody was raising about multicollinearity. I don't see any any evidence of large scale or problematic multicollinearity here. But one place where multicollinearity is coming is between uh, where is it? Just a moment. Just a moment. Because my screen has so much of content on it. I'm not. Yeah, I can see it now. See one area where why is it sharing like this? Okay, fine. I'm sure you can see. Like it is written here. See, I don't know if you can see my mouse on the screen. Yeah, you can see my mouse. It is taking some time to buffer, but you can see that. So I'll share this photograph also with all of you, later on in the group. Have a look at it. Uh, other than that exam score, this first one, entire line, and then this one. Other than exam score area, we don't see any high correlations anywhere. So that multicollinearity problem is not visible. Getting it? So this is sleep hours and hour study. See, somebody was saying sleep hours and hour study could have high multicollinearity, but as of now, there is no evidence. It doesn't mean there is no multicollinearity. From a correlation perspective, it is not there. Somebody is asking for how the graph came. I'll answer the question. So just give me some moment. Okay. Achha, with regards to the significance of each of the correlation coefficients, somebody has asked, that I will show you tomorrow in eViews. Unfortunately, in Gretl, we don't have that capability. It does a common test, correlation test, significance test. But for each variable, if you want that significance of each correlation coefficient, that happens in eViews, which I'll show you tomorrow. It gives you result with significance test for each of the correlation coefficient. That I'll show you tomorrow. So please wait till tomorrow for that. But if correlation are so low, I mean, there won't be much use. When correlations are 0 or near 0, significance test will really not add much value. When they are relatively high, above +2 or -2, then that importance of significance test comes, to ensure that we are not having something because of sampling fluctuation or something. But I don't see any evidence of multicollinearity, at least now, through correlation. But multicollinearity is different than correlation. Okay, very important. Okay, multicollinearity is different than correlation. It can have different implications, but yeah, if correlation is not there, you can be quite assured about it. Yet, so last stage, okay, the last thing that we are going to do now, I'm again sharing that core Excel, Gretl file window, main window. On the main window, now we go for the option model, okay, the option model, and then we go for the option ordinary least squares. There are so many other options like instrumental variables, two-stage, GMM. There are linear models like weighted least square, heteroscedasticity corrected. Understand, OLS is the foundation, the simple OLS here. Unless and otherwise you have a strong reason that some of the assumptions are being violated, which assumptions, we will look at them tomorrow. Only then you go for all these options. Otherwise, you don't need to. Don't deliberately try to use something new. Otherwise, you will end up sacrificing quality of your results. For looking more technical, you will end up sacrificing quality of your results, because unless violations of assumptions are there, OLS remains the gold standard. It is the gold standard. You should not disturb it. Unless there are violations, then you can start looking for alternative options like maximum likelihood estimators, which we use in logistic regression. All right, so here we go for the option OLS. Now, which is our dependent, I'll share the next screen. Once you press OLS, another screen will open. This is how the screen would look. And in this screen, now you need to specify your dependent variable. somebody is asking how is multicollinearity identified. That identification, madam is going to take a session on multicollinearity. She will be talking about it. But the first identification is correlation. Look at the correlation matrix and heat map that I've showed you just now. If X variables are having very high heat maps, okay, in terms of correlation, there is a sign that there could be high multicollinearity. But there are other various ways also, like variance inflection factors, etc., that the person who teaches that topic will teach you. So what is the dependent variable here? Exam score is the dependent variable. So I click on exam score, press on the blue button. So it converts it and recognizes it as a dependent variable. I set it as default. So whatever further estimations I may do by changing variable, dropping variable, adding new variable, exam score will remain the Y variable, dependent variable. What are the X variables? I'm by default taking all the X variables of my interest in actual form, not in standardized form. Okay, in actual form. So I press on the green button. Everything is included. Now it asks you an option, robust standard errors. Okay, just a moment. So don't go for that option right now. It asks you for an option, robust standard errors. Don't go for that option right now. When there is certain problem like heteroscedasticity, cross-sectional data is marred with heteroscedasticity. So at that time you can adjust for heteroscedasticity and give you the estimate. But as of now, we are not getting into all those tests. Don't ask me that. The concerned expert will teach you all those things. You know? So after selecting the Y variable, X variable, I press the button OK. Okay, once you press OK, another screen will come, the model estimates. The model estimates here in front of you. This is how Gretl presents the results. Never ever present the result. Never do Control A. Okay, never do Control A, then right click, copy, and directly put into your research paper or book or project, whatever you're doing. Always copy paste this in Excel or Word. Remove unnecessary things. Create a good table. I'll share some good tables with you. Okay, somebody is asking to repeat. Again, I'll repeat this step. All right. I'll go back to actual Gretl screen. Actual Gretl screen. All our variables are there. We go to the option model on top, right second one before the help option, model. Once you open model, the first one is OLS, ordinary least squares. Press OLS. Okay, once you press OLS, another window will open. This window will open. Here you have to select the dependent variable, Y variable, which we have selected as exam score. Other variables are our independent variables, regressors. Fine. Y variable is defined, X variables are defined, constant is always there. Don't remove constant unless and otherwise there is a strong reason or you are doing a specific kind of modeling where it will come. Don't remove the constant. Then ignore other options, just press the button option OK. Once you do that, another window will open. Once you do that, another window will open, which will show you the Gretl result. Now 1-2 minutes more, 3 minutes more, then we will end. This is the window that will come. This is your actual estimated model. If you see the results, the title says model 2. Why? Because I did it once, then somebody asked a query, I again ran the model, so it numbers it as the second model. The number of times you do it, it will keep numbering those times. So if you've done it 200 times, it will show you this is the 200th model you are working on, and that should generally not be the case. In 3, 4, or 5 iterations, you should be able to come to your final model. Some iterations are required, some trial error is required. That's natural. This is social science, not pure science. We don't have RCTs, randomized controlled trials. But it should not be 150, 170, 200, 250, 300, 500. And for 1 month, you are estimating 10,000 times and then you have the final equation. Then that means you started wrong. Okay, that means you started wrong. So you have this output. It says the model type, which is the OLS estimator. You have used the OLS estimator. What do I mean by OLS estimator? You see this coefficient, hours studied, attendance, sleep hours. Then you have coefficient. This coefficient show how these variables, hour study, attendance, sleep hour, how do they affect your dependent variable given on the top, mentioned on the top, exam score. That is what it explains. Okay. So first you look at the signs of the coefficient. Always look at the sign first. The signs are the main thing. Your theory dictates the sign. It may not dictate the size of the relation. That's an empirical question. That is why you need to do econometrics. Theory does not say it should be exactly 0.28. In some situation, it can be 0.28, 29, 0.51, 0.99, 236.35. That's econometric question. But the sign is definitely given by theory that you should all know in advance. Okay, like we had expected that more sleep will help to improve exam score, but in our study it is not the case. More sleep is showing a negative impact. But if you look at the p values, the significance of this, okay, what do I mean? Tomorrow we will again go through the same data set and we will start directly from this window. Okay, this, you know, these are all based on sample data of 6,600 students. And let's say you are interested in only those 6,607 students, then you don't need to worry about p values. Understand this. You don't need to worry about all this p value. Why? Because this is your population. This is all you are interested in. These are your estimate results. These are your parameters, population parameters, these coefficients, parameters. But Gretl doesn't know that. You know that. But if you are having data on 6,600 students, but you are interested in lot of other students, let's say your university has 5 lakh students, 1 lakh students, 70,000 students, and you are randomly collected, the assumption is you are randomly collected data on the 6,600 students, then you need to go into all this p-values, standard error, t-ratios, etc. You want to ensure that these coefficients represent or come from a population which is what you are interested in. Getting it? Then you need to be careful. Then you need to get into p-values, standard error, t-ratios particularly. So it presents all those results. Okay, it presents the coefficient values, that is how much this coefficient, which is our study, will impact exam score, how much will attendance impact exam score. Remember, all the coefficients, how are they measured? They are measured in terms of the dependent variable. That is the 0.29 is actually 0.29 marks. So our study, if it increases by 1 hour, the marks increase, exam score increases by 0.29. Most results of variables getting high significance is not possible. Was the feedback given in seminar? And what might be the cause? Can you explain, sir? See, it is absolutely fine if variables are having all variables are significant. There is nothing wrong in that. You know, I am opened this. I'll show you. That's fine. There is nothing wrong. It's more of a concern in time series data. That happens more often because if you are not detrending it, not taking it stationary, not checking for correlation metrics, you might end up using data which are highly correlated, and then you will see everything is significant and everything looks goody-goody, but that is not the case. But in cross-sectional data, if there is high significance amongst variables, it does not mean it is bad. If your theory is correct and results are good, it is good. You can show it. You can happily report it unless there is multicollinearity. If there is, but there is no multicollinearity evidence in this data set. I have done that test also. I'll show you right now. So this result is actually good. The data set is good. Why is it good? Because it was conceptualized correctly, measurements were done correctly, data were collected very systematically, cheating was not done in collecting data. So when you do all that, your results are going to come good. Okay, your results will come good. All right. Fidos sir, 2-3 minutes more. 1 minute more. I'm ending in 1 minute. Last 1 minute.
Yeah, actually, you know, our meeting is time bonded, so
Okay. So
I want, you know, to take the question and answer session
Okay,
before
okay,
the
okay.
meeting ends. Yes,
Okay,
please
fine.
go
So
ahead.
we will end the session here. Tomorrow I will show you further things on this, but we will start tomorrow from here only. All right. So with this, we end the session. Thank you so much, and we go for question and answer round, sir.
Yeah, thank you so much, sir, for your great session. Participant can write their queries in the chat box.
Yeah. So I already have some of the queries. Let me quickly take them up. Okay. How do we export the output? You can, as I showed you on that estimated model, press Ctrl A, press right click, copy, and then you can paste it in your Word file, and in your Word file you'll have to adjust it, put it in table and do some manual work, or you can directly take it to Excel also you'll have to do some adjustments. So in that sense Gretl is a little old school, but other things are really good. So this is not a big problem for you. Copy paste it in Word and then convert it into table or whatever form you want. Can we mute and ask the question? Unmute, I don't know.
Yes, you can unmute yourself and ask.
Unmute yourself and ask one by one. Don't jump
Hi.
everybody.
Yeah. Hi, sir. Thank you for the wonderful session. Sir, two questions I'm having. First question, whatever we have studied now with the help of this Gretl, can we do it in the Excel itself, what we have learned yesterday? Is it possible?
So whatever you done yesterday, can you do it in Gretl? That is what you are asking.
No, sir. Gretl, can we do, since I'm okay with the Excel, can we do whatever we have in this Gretl in the same Excel application?
No. As
No.
far as, see, up to the estimation of this equation, OLS estimation, you can do that. But Excel will not give you much output. It will give you very bare minimum output. So if you want to go for diagnostics, what you are going to study in the next few lectures, like heteroscedasticity,
Okay.
autocorrelation, all those things cannot be done. You will have to do it manually. You have to study the whole formula, create that formula, create macro in Excel. That's too much. Learn Gradle. That would be much better.
Okay, sir. Another doubt I'm having regarding the conceptualizing the theory you have been saying starting session onwards. So actually, I'm struggling to create the theory. My area it is labor economics, garment industry. So I'm
Great.
not able to complete my synopsis, and I'm struggling to create the theory and to continue. So, is it the theory what you meant? It is, sir, the already existing theory in the area in economics, or
Yes.
should we create a theory? What
See,
it means? Can you?
see, unless you are analyzing something which has not been done so far, you will have to depend on what has been done so far. So, if what you do is you on your WhatsApp, you send me the topic. Let me have a
Okay.
look at it. If the topic is well established, definitely there is well established theory. Of course, theory won't be in one place. You'll have to study top quality, say 15, 20 or 25 articles. From there, you will identify this is your Y variable, which are those X variables, and why are they related with each other. You will develop that frame. So that is how you have to
Yes.
develop theory. That's the only
Theory.
way. And that's
Okay.
you have to sit down and do the literature review very intensively and study good literature, most important.
Okay, sir. Thank you. Thank you, sir.
Yeah. Next one, please. Next one can unmute, tell your name and ask the question.
So,
Yeah.
so you have said some website name to get the database for the practice.
Kaggle. Kaggle, kaggle.com. You register yourself. It is free registration. And there are a lot of data sets you can download for free. This data that I have shared you, I have taken it from Kaggle itself.
Okay, thank you, sir.
Yeah. Next.
Sir, I have one more question, sir.
Please.
This is Dr. Raja from New College, sir.
Okay, Dr. Raja, welcome.
Yes, sir. Sir, I have a little doubt about, you said about X variables and Y variable, right? X variables are explaining Y variable, right?
Correct.
Correct, sir. Right. So in such a case, I'm studying X variables, so many variables. If I missed some variable when I'm studying, out of that missed variable, out of that variable which I studied, some of variable which is not considered. You
Correct.
said that that variable maybe comes under error terms, right?
Correct. It definitely goes into the tomorrow. That is what we are going to discuss. It goes into the error term. Yeah.
Okay. If I'm not studied before, later I'm studying the including that variable along with the previous
Old
variable,
variables.
previous variable, then we will study in later, right?
Correct.
So if I'm independently studying, if I'm studying only one variable, then I will combine with previous data. It will give a same result, or it will affect the entire data.
It may affect it. See, as far as the overall results are concerned, by results I mean the signs of the coefficient. Okay, the sign.
Okay.
Most important is sign first. Then comes the size of the coefficient. The sign, negative or positive, that should if your data quality is good, if your theory is correct, you have done things correctly, then the signs will remain the same. Some minor changes may occur in the size of the other coefficients, or if that new variable that you have included has very high outliers, very large value or very small values, that can also create problems.
When I am later, when I am studying
listen, Dr. Raja. Third, if that new x variable is having very high collinearity with the older x variables, then also it will change the result. These are three things that I can tell you. Unless it is not highly correlated with other x variables, it is measured correctly. Which one? The new x variable. Unless it is, if it is measured correctly, if it does not have high multi-collinearity with other x variables, you should be fine. Your results will broadly remain the same. Your conclusions will also broadly remain the same. It should remain the same. If it is changing, there is some problem in your original model.
Original data, right.
There is some problem.
Thank you very much, sir. Thank you. Great informative session, sir.
Thank you, Dr. Raja.
Hello, I'm Dr. Ismat Naseem, and first of all, I would like to appreciate the whole session that went very well.
Thank you.
And indeed, Gretl is one of the new addition to my collection of softwares.
Oh, that is so nice.
I just want to know one question. I just want to know one thing, that how Gretl is better than eViews. As I'm one of the person who is using eViews very frequently for the time series data, even for some particular measurement of or calculations of panel data, I also used eViews. But I want to know that how Gretl is different from eViews and how it is more useful than eViews.
Okay. So with regards to comparison between Gretl and eViews, both have their own plus and minuses. I use both. Tomorrow's session that I'll be conducting, I'll be using it with eViews. So one major difference between Gretl and eViews are the environments. Gretl is an open source environment, free of cost. New updates will come, new additions can be done without paying a single penny. In eViews, either you have to use a pirated version, which is a big problem and a legal issue for many institutions. And second, the user friendliness of eViews is quite less. You need to spend a lot of time to study it. Of course, eViews provides some better capabilities than Gretl. For example, more advanced versions of econometric modeling can be done much better in eViews. But if you talk about a good quality intermediate empirical research, up till that level, I believe Gretl is one, cost effective. There is no extra cost. It's an open source platform. It is intuitive and user friendly. You could have seen today how quickly you can get hold of Gretl. Third, it has add-ons which you can add free of cost without worrying about pirated version, license, etc. Fourth, it is very easy to shift from Gretl to Excel to Gretl. So these 4 points are something that I feel makes it superior to eViews as far as intermediate level empirical modeling is concerned. For more advanced version, eViews becomes definitely better. For advanced panel econometric models or state space modeling, their eViews data are definitely much better.
So we can take now last question.
Yeah, Gretl is available in MacBook. Yeah, I'll share the page for that. You can go to Gretl website, Google it. It is there in MacBook version is available, definitely. Yeah.
If anybody is having any question, one question we can take now because we are really, out of time.
Yeah.
So I believe there is no question.
Yeah, we'll end this.
Deepti is there?
Yeah.
Yes, Deepti.
Yeah, I guess there's one more question, sir, coming.
Yeah, please tell me whoever wants to raise a question.
Yes,
Yeah, Ashia.
Yes, I asked about the lag value during the session. After doing the stationary test, I actually reported that these lag values.
Correct. So you do one thing. You send me the because that question will require a little longer answer. So let's not do it right now. We need to end it. You send me that question personally on WhatsApp. I'll definitely respond to you, just like yesterday. I will definitely.
Yes, sir.
Yeah. We can end the session, Deepti.
Yeah. Yes, sir. Thank you so much for this wonderful and insightful session. I would like to extend our heartfelt gratitude to Professor Dr. Bhagirath Baria for this insightful lecture on the fundamental of econometric modeling. He covered the basic as well as more advanced issue in the lucid manner. Actually, we are running short of time. Otherwise, the session was so wonderful, sir. A special thanks to Jammu and Kashmir Economic Association, Dr. Firdaus Malik Sir, and OP Jindal Center for Global South for their exceptional efforts in making this event a grand success. Also, last but not the least, I want to thank each one of you for being a patient audience and your participation and enthusiasm, which we can see in chat box and the queries also. All this made this event more thoughtful and insightful. Thank you so much, sir. Thank you all for your supports. Have a great, thoughtful Tuesday ahead. Thank you.
Thank you, Deepti. Thank you so much.
Yeah.
So let me take opportunity to express my words about this wonderful session. So once again, on behalf of Jammu and Kashmir Economic Association and General Center for Global South, I would like to extend our heartfelt appreciation for this phenomenal, exceptional session Dr. Bhagirath conducted on theoretical understanding of econometric modeling and the ability, the way you have convey the complex concepts with clarity and depth. You know, it has truly enriched our understanding. And the patience, and the patience and enthusiasm you brought to the session was contagious. It was, really engaging to everyone, for every one of us, and fostering such a great environment, of learning and curiosity. Your insights and real world example, you know, definitely, helped us to bridge this gap between theory and practice, making the topic accessible, and it was really, reliable. Thank you once again for your dedication and the valuable knowledge you have shared. We look forward for enlightening session as we are connected, and tomorrow we will be having one more wonderful session. So once again, thanks for your time and the great effort you have shown. So now let me set off the